Hi Mayhill, welcome to Science Week. Well, the teachers have all been really busy planning this week for you guys to really enjoy from home and from school. And we've also got our scientific bug and scientific hats on, so we've been creating some mini experiments for you guys to possibly practice at home as well. You'll see from some of the experiments that they don't go quite as planned, so perhaps you could even do better than we do. Send in your videos and show us what you've got up to. Thank you. Have fun. Got here some bits to hopefully make some mini lemon volcanoes. So I've got a lemon, I've got some bicarbonate of soda, or the scientific name is sodium bicarbonate. It's very random. I've got some food colouring, I've got some yellow, and I've got some blue food colouring. And I have got a long pokey stick skewer, and I've got my knife to cut my lemon. So I'm hopefully going to make two very mini volcanoes. So my first thing is actually, I've just realised I'm going to have to cut off the bottom as well of the lemon. So I'll cut off one bit and I'll cut off the other side of the lemon as well. It means they'll both be flat at each end. Then I'm going to cut them in the middle. So I've got two halves of my lemon. I'm then going to add some blue food colouring. I'm going to put some blue food colouring on one of them, on that one, and on the other one I'm going to put some, well actually yellow is lemon coloured anyway, but I think it might go a bit darker, so we're going to put some yellow on there as well. There we go. Let that kind of soak in. Put the lid back on that one as well. Okay, now to add with this, to add a little bit of froth, hopefully, into it, we've got some fairy liquid as well. So I'm going to put on some dishwasher liquid and put that around it. And same again with this one. Now what I'm going to do with the skewer is I'm going to now poke some little holes into the lemon, which makes the food colouring and the washing up liquid hopefully go a bit further down into the lemon. Move that one that way because some of that has gone the other way. It might be that it's gone too far. That's to the other side. Right, so that is there. A few holes in there. Now I'm going to add the sodium bicarbonate. And what we are hoping is going to happen is we're going to hope for a chemical reaction, which is part of the sodium bicarbonate and the citric acid in the lemon. We're hoping that it's going to create carbon dioxide and that it is going to create some sodium citrate as well and form some little mini volcanoes. This should hopefully just sit on the top for a minute and there as well. And then as we sort of push it down, manoeuvre it around, it should start, oh look, there's a little bit, should start exploding a bit more. You can see that one? Getting our mini volcanoes going on. Maybe it's not quite lemony enough. Maybe if you did a fresher lemon it might work. Not sure. Quite a nice little volcano going on. Let's see this one. Oh, look, there we go. We can see this one. I think it would very much depend. Oh, what's going down the side? I wonder if you could get a greater explosion going on than I can. There's a nice one going on. And there we go, mini lemon volcanoes.
week I'm going to show you an experiment called the ghost glove. So you need some vinegar and some baking powder. You need 3 tablespoons of vinegar in your glass, 2 tablespoons of baking powder in your glove, and you can see I've pushed it down here into the fingers. So you secure the glove around, making sure you haven't got any bubbles, and then lift it up to allow that baking powder to go in, and you will see that it's beginning to react in the glass.
I'm going to show you how to make a lava lamp with a jar, some sunflower oil, some food colouring, water and some bicarbonate of soda. So first of all, open the jar and pour the sunflower into the jar about halfway up. Actually, I'm using vegetable oil, but I think that's okay. Right. I've got to add some drops of food colouring. Interesting how the food colouring drops in. Then we top it up with water. And then you put a light on behind it, and you get, oops, and then put a spoonful of bicarbonate of soda in. So I'm gonna do a little guess, and then we're gonna put the lid on and see what happens. I'm going to try and giving it a little shake to see if that will start any action going. Oh, that was a bit rubbish, wasn't it?
Try and get an egg to float. In here I've got normal water, and in here I've got normal water, and I've added in some salt, so it's like the sea. I've added in enough salt so that, and then I've stirred it so it dissolved, so that the water is nearly saturated. Okay, so I've made a salt solution. I'm going to put one of the eggs into the normal water. like so, being very careful not to break it, and it's sunk to the bottom. And I'm hoping with this one is that if I put it in the salt water, then it floats, and it does, and it floats like that. Now this is the clever part. This is the clever part, because what I'm going to do is I'm going to take this out, and I'm using two different hands because this one's got salt on it and this one hasn't, so no salt on this one. I'm going to take this out. So this was right at the bottom and that's right at the top. I'm going to take this out and pour in half of normal water into here. And I'm going to take this out. And I'm going to pour half of salted water into here. What do we predict is going to happen? Right to the bottom, now right at the top, predict right in the middle. Let's hope if it works. Can't really see. Let's put that one back in again and see if that one went to the fully bottom. Yeah, so that's right at the bottom. So it sort of has done it, maybe with taller glasses. So there we go. We have sinking and floating eggs. Okay.
Hi Mayhill, for Science Week I'm going to show you an experiment called Magic Milk. You will need a dish with some milk in it, some food colouring and a Q-tip with some dishwasher soap in it. Now you put the food colouring in blobs on top of the milk, and because it is less dense than the milk, it sits on the top. Not very much in there. And then you take your Q-tip with your soap and it breaks the surface tension of the milk, so it moves that colouring around. And here's take 2 of Magic Milk experiment, because my other colours all mixed together, so I'm going to try with just one colour. So my blue sits on top of the milk, and then I use the soap to break the surface tension, and it moves around.
Okay, so going off on Mrs. Davies' experiment with the milk, I thought I'd try milk in a different way. So I've got lots of pepper. I'm going to sprinkle pepper all over the milk, all over the top of it, so it completely covers the milk. Just like that. There we go. Now I'm going to try and get some of this into a Calpol bottle syringe, because that's the only type of syringe I've got in the house. There we go, got a little bit in there. There we are. Okay, and I'm going to try and drip it onto here. What I'm expecting to happen is for the pepper to go to the sides, because it's going to break the surface tension. Let's see. Wow! Now that worked quite well. Let's try again over here. There we go. But that wasn't as impressive as the first one. I much prefer the first one. Let's see if it does it again. Let's do more pepper. See, because the surface tension has been broken with the dishwashing liquid, it now won't sit on the surface. Pepper will not sit on the surface now. And there we go, surface tension.
Hello, I'm going to have a go at an experiment that defies gravity. So what you need for this experiment is a glass, a piece of card and some water. And I've brought a safety bucket with me just in case I need it. So this is what you do. You fill the glass up to the top, right up to the brim with the water. Just very carefully, put it down. Might just have to top that up slightly. Okay. Then place a piece of card over the glass. And this is where I need the bucket, just in case it goes wrong. Here we go. What should happen is, I should be able to turn the glass over and all the water should stay inside the glass. And my daughter who's filming this is looking very dubious. Okay, here we go. Ready? Ta-da!
Okay, so for this experiment, all we have got here is we have got a tray of ice cubes and I have got a selection of materials. Now, normally I'd be going on to about fair test, making sure that everything is the same. It is very difficult to make sure that the ice cubes have exactly the same amount of liquid in them, but I've tried my hardest. I will only be using similar sized ice cubes. In terms of the equipment I've got, yes, they are all different sizes and yes, they are all different shapes. However, majority wise, they are all the same height across, depth wise, mostly apart from this one. And also when I put, because I'm going to put an ice cube on it, the ice cube is only going to take up that much space on it. So the space will be the same on this one, this one, this one, this one, and this one. So even though it's a larger piece, it still is only using up the same amount of space on it. Okay, so mainly this is as fair a test as we can do in the home with everything going on around us. So what I've got is I have got various different materials. I have got some metal, got plastic, I've got wood, I've got a different coloured metal. I don't know if it's a different metal, but it'll be interesting to know. So I don't know. I'm going to put that there as well. I've got slate as well, and I have got stone. It's got a pretty butterfly on, but I've got stone there as well. Now, when I touch these, when I feel these, I can actually feel different temperatures within them. I can feel that in general, these two feel like the coldest ones to me. Ideally, you'd be checking those as well. So these feel the coldest. In fact, that one feels colder to me than that one. So I'm going to put them in order of how cold they feel. That one feels colder, then that one. That one feels colder than that one. That one's there. And I think that's quite a tricky one. Maybe there. I'm not sure, but that's quite tricky. But I think this is the coldest. So on. Warmer, 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 warmer. Okay, that one feels warmer. All right. Now what I'm going to do with them is very much within quick succession. I don't have 7 hands, so I can't do six items. But you could have as many as you want or as few as you want. It's ideal to do at least 3, but sometimes scientists say 5, and I've just found 6 quite similar type things. Mainly coasters, actually, 2, 3. Pringles pot lid and some jar lids. So I'm going to put an ice cube on each one and we're going to watch and we're going to see how long it takes the ice cube to melt. It sounds like it's going to take a really long time. Right. 6. Right, and we are just going to watch. Probably had a minute or two. Oh my goodness, for this one. Look at this one, look at the water on that one. And going around there. And the water on this one. So if you remember, I said that these two were the coldest. The slate and the stone felt the coldest overall, over all of them. But they seem to be melting the ice cube the quickest. This one is actually melting quite quickly. These two are still yet to melt. These haven't melted at all. But these are really going for it over here. This is a really good experiment to show what an insulator is. So all of these materials, these two are very good, not very good insulators. These are not very good insulators here. So we've got at this side, this is a really good insulator, wood. And plastic is a really good insulator. This metal doesn't seem to be a very good insulator. And this one does. I might swap those two round actually, because now we can see the right order of how it's melting. So we've got here, these two are not very good insulators. An insulator is an item that will hold electricity or heat or cold inside it and away from other objects. And these ones are not doing that. They are actually pulling that cold in and therefore melting it quicker. It is not a good insulator. And the weird thing is, and this is where it feels very, very strange, is that when you do touch these, these feel really cold. This one feels quite cold. This one feels a bit cold. These two feel warm. What is weird about science is that all of these coasters are actually the same temperature. But because these ones, the slate, the stone and the metal, not good insulators, they drag your heat away from you, so it makes it feel like it's colder. So what you're actually feeling when you feel these is you're feeling your heat being dragged away, and they are actually the same temperature throughout. It's something for you to try at home and see for yourself. This one is just about to go onto my table now. I think actually this stone has melted the most out of both of them, and we've not been doing this for that long. That one's not melted at all yet. Still not done a thing. There's a little bit, but nowhere near where the other one was. If I was being a proper scientist, a full-on scientist with this, what I would do is I would weigh the ice cubes before, weigh the ice cubes afterwards, and find out the total difference in weight that has been melted from the ice cube. I think I might leave it there and let you guys do your own one at home, because it is going onto my table now. This one, the slate one and the wooden one. Simple experiment, cheap experiment. It's quite interesting to watch.